All right. Prime factorization is really, really important for doing a lot of things that are coming up. I'm going to go over what this actually is, right? So any kind of prime number cannot be divided by anything but what? 1. Okay, so that's badly underlined. Okay, so it has two factors, itself and 1. So most numbers are going to run to composite numbers, right? A whole number greater than 1 has 2 or more factors. Okay, so the most important thing, we did this thing about divisibility rules. You have to remember 2. What are the rules of 2? It is an even number. 3, remember divisibility rules. When you add them all up, you add the numbers up, right? It ends up being divisible by 3. An example of that is, say, 36. 3 plus 6, right, equals 9. And you can divide 9 by 3 as you go to 3. So you know that can be divided by 3. The other one's going to be like 5. That's the other one's going to show up. Things like 7, 11, 13, they'll show up at the end when doing this. But these 3 guys are the most important ones. And how do we know what 5? The number ends, right, whatever you're using, ends with either a 0 or a 5, okay? All right, that's how we remember this. To show this, they have a couple interesting things. You've done this in 5th grade, this factor tree, okay? I do not do the factor tree, and I'll show you why. I use something called the hockey stick method, okay, when doing a number. I'm going to take the number 36 because that's their example. I'm going to show you how I do it, and I do it this way for a reason. It makes it much easier to look at all your prime numbers. First thing I do is I look at my things. I got a 2, a 3, and a 5. I can tell right now it doesn't end in a 5, so he will not be a factor in this entire thing. It doesn't end in a 5 or a 0, right? So I take the first one. 36 can be divided by 2, right? It's an even number. So 2 is a prime factor. So I circle it. And then I go, what times 2 equals 36? I know it's 18. It's still even, so I keep going with the 2. So once again, 2, right? Then you end up with the number 9. Oh, divisible by 3. I know that for a fact. So it'd be 3. And the other factor, of course, is 3. And this is where I come up with the hockey stick method. It goes down like this, turns this way. Looks like a field hockey stick. So essentially, I don't write all this extra stuff. It's kind of like, oh, this factor tree makes no sense. I just wrote it like this, right? In fact, I always do the first one being a 2 because it's the most identifiable. It's even. You can say, can it be divided by 2? Yeah. Then you go from there. This other method, you can do it this way, except say how they're doing extra things. If you always think that these guys are composite numbers, you don't even, it's one less thing I got to do. I don't even box it. It kind of looks like this, all right? So I'm going to try another one down here. All right, make a factor. I'm going to do 45. Oh, this will be fun, right? 45. Remember my numbers, 2, 3, and 5. I immediately see the 5. Identify that. That's the first thing I'm going to do. Take the 5 out. 5. Okay, that's going to be 5 times what equals 45? 9. Then I know 9. It's 3. 3. That's a small hockey stick. It just goes what? What is 1, 2? Isn't that easy? Look at that. Super easy doing it this way. And I'll do one more. Let me grab something silly. Oh, let's do 66. Okay. I think you'll get the hang of it when you start doing it. It's not a factor tree. I call it factor hockey stick. 66, 2, 3, and 5. I'm going to go for the 2 first because I know that's even, right? 2. Put a circle around it. What does this end up being? 2 times what equals 66? At 33. Can that be divided by 3? Yeah, because 3 plus 3 is equal to 6. So I'm going to take the 3 out of this, right? My other number is going to be an I11. All right. 11's prime. You can't do anything with it. Once again, look, it's my hockey stick. So this is sort of fun and games and things like that, right? But let's take a look at this guy up here. You're going to be doing this for the homework. Express an exponential form, then find the product. This this is fairly easy. Exponential forms is how many 2's do you have and how many 5's you have when we're doing numbers like this. I'm going to take number 1. Oh, let go. There we go. Number 1, I have 5, and I got 2 5s, so I put 5 squared times how many 2's I got? 2 squared. Okay? Now, there's a lot of different ways to look at this. It's really kind of easy, right? You could say 5 times 5. This would be 25. Times 2 times 2 is 4. You would get 100. Okay? That's an easy way of doing it. There's a lot of ways to look at this, really, when they look like this. You could say 5 times 2, right? And then we go 5 times 2. I mean, it really is a bunch of ways to do this, right? 5 times 2 is 10 times 10. You still get 100, right? Cool thing about math, there's more than one way to work these things, right? So we do these things, you try to find the product, you just multiply them all across. And it should be kind of straightforward, right? Now, I don't want you to use your calculator for that. You have to do this by hand, right? So you have to understand what's going on. So you got to get your MathFax Pro up and running for these things, right? Let's take a look at these down here. I'm going to find by prime factor and then write it in exponential form. Let's do 21. That's 125. Let's do this. So I have 125. I got the numbers 2, 3, and 5. Well, first of all, immediately I see the 5, I go with the 5. So this is the one I'm going to use, right? So I'm going to take this, and I get some little squinched here. I'm going to put 5 here. 5 times what number would be 125? Actually being 25, right? And then obviously I could take 5 out of it again, because I see the 5 there. Becomes 5 by 5. Once more, hockey stick. You should be doing all this hockey stick. And the reason why you're doing them that way is because it's going to help you so much later on, right? So if I was to write this, it's 5 times 5 times 5, or in this case, 5 cubed would be your answer. Okay? So this is how you do this section. Hopefully it's not too bad for you, okay?